Let's discuss a question from strength of materials. Basically, a cylindrical thin wall water bottle is given, which is completely filled with water and open at the top. The height is given, which is basically 40 centimeters. So it is 0.4 meters. Okay, and the diameter as well as the diameter is 15 centimeters, so 0.15 meters, and thickness is given as 1 centimeter. That is nothing but 0.01 meters. So everything we have converted into meters. Now the maximum value of hoop stress is asked. And remember, from the thin pressure vessels, you would have learned that the maximum value of hoop stress is basically not the maximum. The value of hoop stress is PD by 2T, and it is same at the cross section. Now this is proportional to the pressure, and pressure is not same. Like if you look at the hydrostatic pressure that is acting, like here the hydrostatic pressure is 0, whereas the hydrostatic pressure here, remember that we are taking gauge pressure only for this, because if you look at the outside, you have atmospheric pressure, so effectively what contributes is the gauge pressure. Okay, because of the gauge pressure only we get the stress. Because if, let's say, if I have the atmospheric pressure only, absolute pressure if I take, and if you have only atmospheric pressure, if it's an empty can without any water, so you have on both sides atmospheric pressure, so then it cancels out, there is no stress developed. Okay, so more or less, we take the gauge pressure here for this equation. So now at here the pressure is 0, whereas at the bottom you have the maximum pressure. So we take that point and calculate the maximum. We actually calculate the pressure there. So pressure here, uh, in a static fluid, the pressure varies with height. It increases with the depth basically, and the formula for pressure is rho gh. So we calculate pressure by this, where rho is 10 power 3, g is 9.81, and height is 0.4. So when I calculate this, I get 3924 pascals. So pressure is basically 3924 pascals, and it is acting here. So here only, because the pressure is maximum, here only you get the maximum hoop stress. So we consider this location. But if you would have seen that in thin pressure vessel, everywhere the pressure was P. So it's immaterial, wherever you take the section, you get the same hoop stress. But here you have to take the section. That's why it's asked in the question the maximum value. So you have to take the section at the bottom, then only you get the maximum pressure, and hence you get the maximum hoop stress. So pressure is 3924. Diameter is basically 0.15. So everything we convert in meters to thickness is 0.01. So this value basically we get as 2943, and we convert in kPa. So 29430 something, so 29.43 kPa, because in kPa answer is asked. So 29.43 is the answer for this. This is a simple problem. Only thing is you have to some bit of fluid statics you have to combine. Thank you.